Hello everyone, hope you all are doing well. This is the third video of our series where we are learning how to generate the Python libraries from start to finish. In the first two videos, we have learned first creating an application, and second, we need to export that application and convert it into the Python library. In this third video, we are going to focus on three main topics. First, we are going to convert our existing library code from non-class-based Python code to the class-based architecture. It means the whole library will be using the class and object-oriented programming methods, and we are going to follow that, including into the test code as well. Next, we are going to look into the PyPi packaging requirement specification and generate various files which are required for us to build the package at local file system, and then make sure that we could use the tools such as Twine to upload the package from our local file system to PyPi server. We are also going to cover how to generate the PyPi API token and also generate the local files such as .pypi.rc, where your PyPi specific credentials are going to store, which will be used by Twine utility to first get the credential and then upload the package from local file system to PyPi server. So there is a lots of new things you are going to learn if your objective is to learn how to build Python libraries locally and deploy them at PyPi server. I just wanted to make sure that please do visit the first two videos related to this series. So what you are going to see in this video is going to make a lot more sense to you. In this step, our objective will be to convert the code which is in API.py, mostly the implementation of our calc method, and convert this whole code to the class-based Python coding. So I will create a new file named API class.py, and what we will do, we will actually implement the API class connection from init to API class. So that's why API.py will be sitting as it is without any change, and the connection from init.py will go directly to API class.py. So here is our API, and as you see that there is a method validate choice, validate values. Here is the implementation code. So let's create a class. We call it calc master. That's our class object, and we need to define the init, some basic class specific configuration. These are just variable. You do not really need it, but it's better to have it. And if you remember, in our class we had these inputs, choice and argument value, so we also need to set them, and this choice variable is going to be passed when the object related with our class is going to be initialized. So that's the choice variable. Next, we need to have the arguments. So we just call them argvs, and those are the variables. They will be used here, argument variables. So that's where these two will be needed whenever an object will be instantiated using this class. Besides that, if you remember, our class has these three variables, so we need to set them also. So let's self.result message, self.result value, self.result status. We also had these choices, so we can take these choices and we can also set them here. These are the choices. Now we are going to use validate choice. Let's take this code only. So it will be define validate choice, and here we are going to use if self.choice is not in self.choices, then return false, otherwise return true. Then another one we are using, which is the validate values, and here let's copy the code length.argv. So we need to use each value in self.v, and if each value not in this, all value return. Okay, so that's our validate values. And whenever we were using, we also setting the result message. So we need to make sure that we do set the result message here. So we could say self.result message. Now in our code, we had these if choice is addition or subtraction or the multiplication or division. So we will create these 4 different methods. So define, perform, addition, and here this is the addition code. If self.argv greater than 0, self, and here we will use the variable result value equals to 0 because we need to make sure that everything is set in local capacity, and because the self dot result value is the variable which is related to the class, so self dot result value. So we will update the self dot result value at the last here. So self dot result value will become the result value, and perfect. There you go. So that's if this condition is right, the total will be created based on total number of variables we have in the argv, and finally we will set that to result value, make it status true, and add the message. Similar to that, we will perform the multiplication. Just create the define, perform multiplication. Let's use the code for the multiplication. And here same thing, self.argv length, and that will be the result value, and here we can just set exact same way. Perfect. I won't be explaining a lot because we have already understood most of the code in the first 2 videos related to this series. Third, we will perform define, perform subtraction. Let's take code. Self.argv, self, and it will be self.result message, and at last define, perform division. Here is our division code, self dot. So we have created 4 different methods which are part of our class. Let's create the another method which is going to be calculate, and what it does, it will just do if self dot choice is equal to addition, then it's going to perform the self dot perform addition. Then if self dot choice is equal to multiplication, self dot perform multiplication. Else if self dot choice is equal to, and the last one, else if division, self dot perform. Completed this, and we need to make sure that before we perform any of these operations, we call first choice and second choice. So we will create a check here. We'll say if self dot validate choice and self dot validate values. So we need to make sure they are correct. So what we can do, we can actually check if it is true, then we perform everything, or we have another option, if not and not, if any of these not, then we could actually return here. So we need to make sure that we have ability to return something. So remember our return was, we were returning these 3 values. So we need to return similar to that. So what we could do, we could actually create a new method called defined package results, and it will be return self dot. So we had a status was our very first result status, then self dot result value, and the last one was self dot result message. So this is how we were returning. In this scenario, return whatever we have result, and if everything is right, then at the last return self dot package result. That's how our code we have changed from a non-class based code to the complete class based code. First, we have defined the class, initialize the class with result specific parameters and class information, and here are the 2 values which are passed as the parameter when this class is going to be used to create or instantiate the object. Then the user is going to make a calculate call, and when the calculate call is going to be happen, it will perform the choice validation and the value validation. If any one is false, they have to be both true, our result will be sent, which is the base result. Otherwise, depending on choice, addition, subtraction, multiplication, and division will be performed. We can go back to our init, and here we will keep this code as it is. And next, we are accessing the src.ramputils.api class, and here we are going to import the class name calcmaster. And here, similar to this, we are going to define calc. So the method is not going to change the way the call was made. Only thing is going to be changed, the internal implementation. Here we will create a new object, calc object, which will be using the calc master, and it's going to take the same choice and the argument values passed to it, and then it's going to return exact same. Here the only difference will be calc object dot calculate and no parameters. So it should be clear to you that whenever we change our code, if you see the change is into this area. So here it was making a call to the previous API calc implementation method or a function. However, here first instantiating the class and then making the class object and calling the calculate method. And the calculate method is this. Rest, there is no change. It means that if we come back and we test our API code, it should work. Everything is okay. Let's try to put 12 here. You see the error. It means all of our code is working. If you would want to make sure that it's hitting our class, we can actually put a breakpoint here, debug the code, and it's making the call in the calculate method inside the class. So that proves that our code is working as we have expected. Just to extend our implementation of library, we can also add another method called the API info, so users can get an idea about how to use the API to access our library. So we will create the method called API info, and this API info is going to return API info JSON, and this API info JSON we have to create it. So let's create the API info JSON. This JSON is going to have the various information related to our library. So here we have name, library name is ramputil. Here is our description, parameters, choice, and args. Parameter choices, we have addition, subtraction, multiplication, or the division. Make sure that the args must be all numeric value, and here are the nodes. So when somebody made a call to API info, we will return this JSON for them. So these two methods are only available in our library. In the next step, we are going to create the wheel file, and we will install that wheel file to our application and validate it. Let's remove these two folders. We are also going to remove this aginfo folder because that was not part of our project. Our original code was in src ramputils folder and our test folder. That's all we had. Here is our setup.py. So here we are going to open the terminal and we are going to create the package. So if you remember, the command was python setup.py bdist_wheel, and we are not creating the universal package. So the package will be created for Python 3 and above. We have validated that our code files are added, and here we could see in the dist folder, the wheel file is created. Now we will go back to our application where we have tested the wheel file in previous video. Here was our project. That's where we were using the ramputils library. So very first thing what we need to do is to uninstall the previously installed ramputil. So pip uninstall ramputils, and after the ramputils is uninstalled, you can see that this ramputils library is no longer available in our Python 3.10 runtime. It means now we can install. So pip install. Here was our wheel file. We are installing it. Library is installed. Now this error is gone. It means ramputils is available. We can run, and oh, that problem came because src.ramputils. Let's come back terminal, uninstall, come back to init and remove this. We should be able to access the API class. Let's see, this code is still working. It's a ramputils.api. It should be ramputils.api. API class, and let's try. Okay, so the code is working, so it must be ramputils.api class, similar to the previous one, ramputils.api. Let's rebuild the package again. We have rebuilt the package. You can come back here. Ramputils is uninstalled, package is removed. As you can see in the ID, there is a module not found error. Let's install it. Pip install. We are using force install. It means if it is installed, it can be removed and then reinstall again. Ramputils is available. Let's run our code. Code is working. At this point, if we try to get the print ru.api, let's see what was the name, API info. Let's run again, and here is our API info, which is printed here. So that proves that our code related with class-based library is working without any further problem. After we have completed our class implementation to API class, the next step is to come back to our test code and actually apply the class-based structure as well. So here we are going to create the class ramp utils test. That will be our class name. We could define the test method. It's just a very simple test method, and that method is going to have this assertion, and within the Python we do have unit test. After you have imported the unit test, you can actually create the class and you can pass the unit test dot test case, and once you are going to use the unit test dot test case, you will have access to various assertion related to unit test, such as self.assert equal, because that's what we are trying to do here in this method, and it will use the parameter this way. It means between this value and this value, these two must be equal. Similar to this, we are going to change all of these values and change them to follow the assert equal structure. The last one for the division, and your all tests are completed, because that's our test api.py. So we need to run using if name equals to main test object is equal to ramputils test, and then test object will be our object, and we are running the test. So the code which we had just making these 4 assertion, now we are completing our assertion using the class-based structure. Let's run the code. Everything is right. If we change it, if you see here, the assertion is failed. Calc addition. Rest of the assertions are okay, because 11 is not equal to 13. If we make here 20, the second assertion related with subtraction is going to be failed, because 25 is not equal to 20. So you get an idea that how quickly you can convert your test code, which was non-class based, to the class based. And after that, everything is going to work as it is. No more changes. So whenever you are creating any Python application, make sure that your emphasis is to write a lot more class-based code, because writing class-based code, your code becomes more modular and looks much more structured, and it's become much easier to use that code anywhere you want and become more functional as well. After we have implemented our test with the class-based code, now we can rebuild our package. The package has been rebuilt again, and we could test it, reinstall, run. Everything is okay, not a problem. Next, I wanted to show you that how you could validate where your package is, where it is installed based on your installation. So we can come to terminal. We can look into pip show ramp utils. So pip is going to tell that where the package is installed. Here we can look into site package and look for ramp utils start. You will find that within the ramp utils, there are 2 folders. One is ramp utils and second is ramp utils distribution in info. And here you can validate that the ramp utils package here has the init API class. Test is not included, And in the distribution info, you could find various files specific to our distribution. And here you can also see that when we have built this package, the package, and here you could see that this is the reason we have created these two packages. One is ramp utils, this distribution info, that's what you are seeing here, and the ramp utils package where the code everything is, that really exists here, and here are the files which belongs to ramp utils depending on your version and the dist info, and rest of these files were part of the ramp utils distribution info. So if we come back here and we uninstall our ramp utils package, these two folders will be deleted from our file system. So let's try this. Pip uninstall ramp utils, and as you see here that ramp util is not available. The package is gone after it was uninstalled. In this step, our objective will be to take our wheel package and deploy it at the PyPi repo where most of the packages are being deployed. And when you are using pip install, most of these packages are coming out from this PyPi repo. So very first thing what you need, you must have an account with the pypi.org. As you could see here, I do have an account for myself as Prodramp. And within the Prodramp account, I can create the project and I can upload the packages. So that is minimum requirement for you to get us started. Next, we can look into the Python packaging project guide. That's where you will get the details about how you could package your project, which will be ready to deploy at PyPi repo. One thing I just wanted to make you clear is that you cannot upload the package at this web interface. You must upload the package from your local file system to PyPi from the command line interface using a project name Twine, and that is what we are going to see. So let's follow this documentation. So here is the library which we have created, tested, and deployed locally, and everything we found is correct in working order. Next, we need to make sure that we are following the structure provided by the Python packaging project guideline. So very first thing what we need is that we need to make sure we add a license file. Let's come back here at the root of our project, create a new file called license. After the license, we need to create a README. Let's add the README. And the third file we need to create, and that should be the pyproject.toml. Now we are going to add some of the content in these two files first. So let's come back to README. So this is just a message I have added as a markdown content. In the license, I can take this sample license which is available here and I can paste it. 2022 Prodramp Inc. Just for sake of completeness. So we have README and license is ready. Now let's come back to pyproject.toml. We need to make sure that we are following the structure something like that. Let's copy this. Our package is ramp utils. Username I will use here as a Prodramp. Version 001. Author I will use the Prodramp team. Email avkash@prodramp.com is sample demo utility. README is connected with readme.md. This one license file is connected with this license file. Requires Python 3.7 and above. That's works fine. Classifier, it's for Python 3 MIT license. So as you could see that most of these fields are correct based on our setting. Our home page, I will replace this with our GitHub for the deep works. For the bug tracking, I can also use the same Python module URL. So that is our pyproject.toml file. So these three files were needed for us. At this point, I need to make sure that we do have the build package installed in our Python 3.10 runtime. Everything is okay. Because now the build package is installed, so we could use the build package to generate the distribution build for our library, which will be deployed at PyPi. So the command here will be python-m and build. When you run this command, you will see that in the dist folder will be created, and the dist folder, the packages will be available. So this build command, what it does, it actually creates a isolated environment for the Python depending on our setup requirement. It copies all the files, build the package for us, test the package for us. If there are any errors, it generates errors. If not, it gives a successful message that the wheel file is available, and for the same wheel file, the zip file is also available. Let's look into the project distribution folder. In the distribution folder, you can find the Python 3 package as well as its tar.gzip. So gzip compressed file is available. It means that command went well without any further problem. The next step is for us to upload our package from local file system to PyPi repo. And for that, I have already asked you that you need to make sure you do have an account set up here, and you also need to generate your API token. Here I'm already logged into pypi.org. Here is my account. Within the account, I'm created an API token within the account settings section. Permission to upload package. The scope for the token is going to cover the entire project. And here is my token ID, which is the ramp utils token. I will add the token. And this is the token which I will be using. So I will be creating a file name .py in my home folder. And that token is going to be stay there. And I will be also changing from token to whatever my PyPi username is. And after I will complete my project, I will remove this token. So if you are trying to use this token, it will not work. So my request. So first we need to make sure that we do have the Twine package installed in our machine. So we could say pip install Twine. It's there. And if you remember earlier when I was using the requirements.txt, I did refer a Twine. That is the reason I was referring for the Twine package, because it is needed for us to upload the package from local file system to PyPi server. So what we are going to do, we are going to create a .pypirc file. That file is going to stay in my local file system and in my user home directory. So as you could see here, cat my user home .pypirc. That is the file which I have already created. This file has a definite structure. Here you need to have the dist utils. You can define index server. So if you are using PyPi or the test PyPi, you need to refer them. For PyPi, what is the repo URL, what is the username, and what is the password. This password is basically your API token for the PyPi. So that's the PyPi PIRC file. And as you could see here, that this is the format which we have used. And here is an example. If you are using the PyPi, your repo URL will be this, followed by username and password. If you also want to deploy on test PyPi, your repo will be this, and you also have to use the username and password. And the same PyPirc can also support the third-party private repo as well. So we made sure that we have PyPirc available with correct information. Now we need to use the Twine. So that is our Twine command. And when you are using Twine, you can use the Twine-h. That's the help version. Then you can say Twine Upload. That will tell you that how many parameters you have in order to support with the Twine Upload. So as you could see here, that if you do not want to create your PIRC file, you can actually pass the username directly and password here, as well as the repo URL if directly. And that's why you do not really need the PyPirc file, which we have created earlier. So your command will be Twine Upload, and you need to select which one you are using. So remember, based on our PyPirc, we have only one index server PyPi. So we want to upload at the PyPi. So our repo will be PyPi. So it will be, as you could see here, --repo, not the URL. So our repo will be PyPi. And then after we want to, which files we would want to upload. So if you remember all the files which are stored here. So let me cancel it. Let me show you that if you see here that our dist folder has these two files which we have created when we run the build command. So these two files will be uploaded with this command here. So let's take this command back, use here. At this point, this command is going to use our PyPi file, which we have created in the user home folder, and it's going to use the PyPi server ID, and based on that it's going to read the username and password. So it's going to read this PyPi, is going to use username and password and select all these files which are available here, and they all will be uploaded. Let's run this command. Okay, so this command, as you could see here, it tried to load, but because I have tried so many times, so it's not going to let me make further attempt. It's going to put me in a queue for at least an hour, and after the queue timeout is happened, then I will be able to connect back. So that's the reason I will not be able to connect here. One more thing I wanted to show you is that most of the times, so many people have complained that whenever they try to upload their package, they are getting these various errors, and most popular is this invalid or the non-existent authentication problem. So if you are getting that error, you will see that so many people have reported the problem, but the solution is pretty much the same. So if everything goes well, you will be able to upload your files from your local file system to PyPi repo. The code related to this whole project is available in this DeepWorks GitHub repo. Looking at this developer program, creating Python module, and everything which we have covered today is available in this ramp utils full folder, where you will get all the files as well as the PyProject TOML, including others files such as setup, etc. And that's where we end our series. In 3 videos, you have learned step-by-step information to generate your Python library and finally package it and deploy it to the PyPi server. So that's all I had for you in this video. Thank you so much for your time, and I'm looking forward to seeing you in my next videos. Until then, thank you so much.